Hello learners, today let us continue with our endocrine blackboard series, and today we are going to discuss regarding anti-diuretic hormone, which is also called as vasopressin. So here we will be discussing regarding source of the anti-diuretic hormone, where it is getting secreted, and regarding the chemistry and half-life of anti-diuretic hormone, and then regarding the action of ADH, and regarding the regulation of antidiuretic hormone. So let's get started. So regarding the source of antidiuretic hormone, there are two different nucleus which were seen in hypothalamus. One was supraoptic nuclei and another one is paraventricular nucleus, and these two nucleus which were situated in the hypothalamus is the main source of secretion of vasopressin. So here what happens, it will be secreted from the hypothalamus and it gets stored in the posterior pituitary nerve endings. So here whenever the nucleus were receiving the stimuli to secrete the ADH, they will pass the secretion, and here from the posterior nerve endings this vasopressin will be released in the blood. Okay, so this is regarding the source of ADH. And regarding the chemistry, it is also a polypeptide hormone, and it is made up of 9 amino acids, which is very similar to oxytocin. In previous video we had discussed regarding this. And regarding the half-life, it is from 18 to 20 minutes, but in case of oxytocin it is only 6 minutes. Here ADH is having more half-life comparing to the oxytocin. Okay, so let us move on with the actions. Regarding the actions of ADH, there are two different types of action. One, it helps in retention of water, which is also called as antidiuretic effect. So diuresis is nothing but passing large quantity of urine. So here ADH is doing antidiuretic effect, that is retention of water. Okay. Then the second action of vasopressin, here comes the vasopressor action. So with the name itself we can identify the action. So vaso is related to the blood vessels and pressor is related to the action, that is constriction. So here it mainly contributes in vasoconstriction. Okay, that's why it is vasopressor action. So now let us discuss regarding the antidiuretic effect of ADH over the kidneys. So this is the afferent arteriole which brings blood towards the kidney, and this is the efferent arteriole which takes away the blood from kidney. And here comes the Bowman's capsule. This one is proximal convoluted tubule, and here comes the ascending and descending limb of loop of Henle. And here comes the distal convoluted tubule, and this is the collecting duct of nephron. So here exactly what happens, this ADH hormone acts over the distal convoluted tubule and the collecting duct and make these two parts of nephron water permeable. So because of the water permeability, all the water will be retened through these distal convoluted tubule and collecting duct through the process of tubular reabsorption. So let's see how exactly it is happening in the distal convoluted tubule. So this is our distal convoluted tubule. So this is our ADH hormone. So what happens here, it joins with the V2 receptors. V2 receptors were nothing other than vasopressor receptors, which were seen in the tubular membrane. You can see here. So it is situated exactly here. So here this ADH and vasopressor receptors join and activate adenyl cyclase, and this adenyl cyclase forms cyclic AMP, and this cyclic AMP activates one special type of water channels which were situated in the DCT and collecting ducts, mainly DCT, that is none other than aquaporins. These were also a simple membrane proteins, and this act as a water channel also. What happens? The cyclic AMP activates it and makes the distal convoluted tubule water permeable. Okay, so once it is becoming water permeable, water will be getting reabsorbed through the DCT and collecting duct. So this is the exact process. And few points regarding these aquaporins. So still now, in case of mammals, 5 types of aquaporins were identified. Out of that, 1, 2 and 3 were seen in renal tubules, and 4th type of aquaporin was seen in brain, and 5th type of aquaporin is seen in salivary gland. So this is all regarding the retention of water action or antidiuretic action of ADH hormone. So with the name itself, it is very clear that this vasopressor action is nothing but vasoconstriction over the blood vessel. So what happened here? Here are ADH. These were the molecules of ADH. It combines with one special type of receptor here, that is V1A receptor. So in case of antidiuretic effect, it is V2 receptor, and here it is V1A receptor, which was situated in the walls of the blood vessels, and it combines with the ADH and leads to the action, that is vasoconstriction. So simple. What will happen because of vasoconstriction? There will be increase in the volume of blood, leading to increase in the blood pressure. So here, whenever there is any problem in the volume of blood or pressure changes, our vasopressor action will be initiated. Okay, so that we will be discussing in the next part, that is regulation. I always find these feedback mechanisms are more interesting. So here let's see the regulation of ADH and how it is happening. Here there are 2 different types of potent stimulators which will lead to the stimulation of ADH. One is decrease in extracellular fluid volume. Okay, so whenever there is decrease in ECF, then ADH will be stimulated, and whenever there is increase in osmolar concentration. So osmolarity, I can say in simple terms, that is none other than the concentration, whether the urine or plasma is concentrated or not with the solute. It is, we can say, as solute concentration. So depending on it also, ADH might be stimulated. Okay. So what happens here, whenever there is decrease in ECF, it will stimulate the ADH, and by stimulating the ADH, what will happen? There will be both vasoconstriction and retention of water. So because of both action, what will happen? There will be restoration of ECF. So this is how it is regulated. So here what happens regarding osmolar concentration? We have one special type of receptors, that is Osmo Receptors. These receptors will identify the decrease or increase in the osmolar concentration of plasma. So based on that, these osmoreceptors which were present near the hypothalamus, they will go and stimulate the supraoptic nuclei and paraventricular nuclei of hypothalamus. and because of the stimulation there will be secretion of ADH, which will be released into the posterior pituitary and through the nerve endings, and from posterior pituitary these vasopressin or ADH will be released into the blood. Okay, so once it is reaching the blood, it will reaches the kidney. There it acts on the distal convoluted tubule and collecting duct, and that then there will be retention of water. So once water is getting retained, the osmolar concentration will become normal. So normal osmolarity of plasma will be retained. So this is how the ADH or vasopressin is regulated. So this is all regarding the ADH source, chemistry and action. So if you have any doubt, you can comment below, or if you have any suggestion for any other hormone, we will continue with the next class. Thank you so much.